Ladies and gentlemen of Algebra Honors, good morning. Good to have you here today. Yesterday we were working on exercise 1 through 15, 1 through 16, which were these types of exercises here. When you go into 17, we're transitioning into what are intended to be like real-world applications of absolute value functions. And so we have number 17, where we're given a diagram and an equation. So I want you to play with that for a second, see if you can figure out something with that. We'll come back to it after I take care of a little business, all right? Mm-hmm. All right, very good. All right. Anybody come up with something on this yet? See, no? Yes, maybe. Okay, with something. Randy, you come up with something on this?
160.
Pardon me?
From the left, it'd be 312.
320?
Right.
So Randy says 320.
No, that was the right.
Oh, from the right. So
From the left is 160.
160?
Yep.
So Randy says right here, okay. Did you work out the equation on it? Or did you just look at the
Kind of just looks
sketch?
30.
Okay, so I'm looking here, you're looking for a depth of 30, and this would be like, that looks like it would be pretty close, right?
Yep.
And what about over here? About 320? Okay. Well, good. That's thinking. And so if we didn't use the equation, that's about what we would say from the graph of what we have. Okay. Did anybody work on the equation at all on this? No?
Like trying.
Okay, now what it is, if you look back at problem, it is that this problem is actually like 1 and 2 here. Okay, that's what it is. I will show you. Okay, so what we have is we have this. Where does it go? Okay, so 30 feet below, what's that? What is 30 feet below? It's D of H, right? And what is? Okay, so if we put 30 on the left side and set that equal to 1/5 H minus 240 minus 48, would that be an equation we could use for this? And does that look right to you? So, if we add 48, will we add 48 to this? Now I'm just going to work to the right. I don't have a lot of room here. Probably, you don't probably either. But, so if we add 48, we get 78 equals 1/5. And we have this h minus 240. And then what?
Times 5.
So if we multiply this whole equation by 5, and I'm going to just kind of work this below here. So 5 times 78 is, what is it?
390.
390. So 390 is equal to this h, absolute value quantity, h minus 240. And how do we separate this out? I'm going to write these down here. How many equations do we get out of this?
2.
2. And the first equation is
390.
h minus 240
Oh, yeah.
equals 390, and also h minus 240 equals
Negative 390.
equals negative 390. And then we add here 240 and we get h
Negative.
equals-
Just kidding. I'm so dumb.
630, is it? That's 630? It is, right?
Yes.
Okay.
On the positive side of it.
And then this one's going to be plus 240.
That's negative 150.
So negative 150. So h is the horizontal distance, so h is this distance. So h equals negative 150. Now, do these answers here look like they're good answers? Randy gave us these, yet we come up with these down here.
Yeah.
Do they look like reasonable answers?
No, you got a negative.
Yeah.
No, they don't. They do not, okay? 630 is way over here someplace, right? And negative 150 is back over here someplace. What happened here to us?
Let's see.
What I will do is I'm going to do something here. One thing we have is we can do a redo on this.
Wait, hold on. I'm gonna need an eraser.
You don't know it's a boat.
The boat sank.
This is the redo on this. What happened? What went wrong here?
Erase all of that?
I'm gonna erase it up to here. What went wrong?
What did go wrong?
I want somebody to tell me.
Is
I
the
want
30 in the wrong place? Should be in the H.
no. Jose, Randy,
390.
Lexi, right?
I don't
Kimball.
understand.
Plus.
You don't get what happened here?
I thought we were looking.
I thought that was right. Should you?
Can you
No.
smell what the rock?
Okay, guys, here. I'll tell you where it is. It's right here.
Bro, I knew that.
Oh, negative 30.
Okay, who said negative 30?
Me.
Yeah.
Randy.
30 feet below. Okay, so now we're going to make this negative 30, and that might fix everything for us now.
Oh, yeah, I get it.
So now we add negative. We add this. We get negative. So we get 18, right? So 18
Oh my gosh, I need a big eraser.
equals
I'm just gonna find
1/5.
out.
C.
And then, same thing, right? Everything we did before is still good. Multiply by 5,
Yep.
right? So we get, is that 90 now? So 90 equals h minus 240. And now we can set up our two equations, which are h minus 240 is equal to
18.
90.
90.
We're at different spots, I'm so sorry.
And h minus 240 equals negative 90. And then we add, is this going to look better here?
Yep. 330.
So Marcus, you say 330, is that right?
Yep.
And then over here, we get 150. Does this match what Randy estimated earlier?
About.
Pretty close, yeah?
Let's go Randy.
Pretty close, yeah.
Good job, Randy.
And this is one of the examples. A lot of times when I make mistakes, I do it accidentally. This time I did it on purpose.
Thanks.
So were you laughing at us when we were writing down everything?
No, no, because you're doing,
You were like,
no, I was not. I'll tell you why I was not laughing at you.
because we were figuring it out.
What do you think happened the very first time I worked out this problem last year?
You probably messed up.
I made the same mistake,
Yeah.
okay? So, but what happens is, this is an example of the real world has different code things, and the word below will oftentimes mean negative. And if you look at, if you treat it like, I said, oh, this is like an XY coordinate plane, and it's negative below this x-axis and positive above. And so it gets you sort of thinking to the real world. So that's one reason I'm not laughing at you, but I wouldn't even laugh at you anyway.
It even says negative 40 right there. Does it not?
Yeah.
On the graph?
Yeah, on the graph it says negative 40, but it's hard to read, right?
Yeah.
So it's a little ambiguous, and you don't have, your graphics quality are not as good as mine up here,
Yeah.
right? So there are a lot of reasons for it. But real world problems are kind of tough because you have to sort of contextualize what's going on there, and it just isn't handed to you on a silver platter, right? This one here, 18, geometry. Find the points where a circle centered at 3, 0 with radius of 5 across the x-axis. Use absolute value equation. And the fact, all points circle same distance from center. So what would you do for this one?
2 pi.
One thing you'd have to say here, that I will put in here, is this will be your x-axis. And your y-axis is going to be something like this, because that's 3, 0, right? So your y-axis is going to be over here. And so you're looking at an absolute value equation. And the fact that all points in the circle are the same distance from the center. I had a hard time coming up with an equation for this, but I was able to figure it out without an equation. Any ideas on this one? Where they cross, you're looking to find out where the circle crosses the x-axis. So it's kind of the way the thing is, where the circle crosses the x-axis. So where does the circle cross the x-axis? No, that's the center. It doesn't cross. Okay, where the circle crossed the x-axis.
Circles already
Wow.
crossing it. 8, it's comma 0.
I'm trying to figure out the point.
Okay, so 8, 0,
Oh, isn't that right there?
that would be one of them, right? What would another one be?
Negative 2.
Negative 2, 0.
So you just get
No, you're not guessing, right? You're looking at it and say, okay, this is cross. So you try to look at it wrong. Now, how would you write an absolute value equation for that? So x, it would be,
Wait, how'd you get 8 and 0?
Yeah, 5 mark.
Oh,
Like 5 to the right, 5 to the left.
oh,
3 plus 5 equals 8. So you would say, I don't want to say x, I want to say, I'll say c, because x is like x. C is equal to 3. And how would you say that? Plus, I know how to do that, plus absolute value of 5, right?
Mm-hmm.
Or
X.
would x go here?
Yeah.
Or x plus 5?
That works too.
But 3
No,
plus,
it would be x plus 3, wouldn't it?
Dang, I should have said that because
Because you're moving 3, or minus 3, because you're
That'd be
moving
5.
to the right.
Yo, Randy's smart.
Ready?
like that?
Yeah.
Yeah.
Okay. And then, with the center be 5. So how about this?
Yeah.
Sir.
Yeah.
And so what we have is we'd have x plus 3 equals 5, and x plus 3 equals
Negative.
negative 5.
Uh-huh.
So what would that be?
Negative.
So x equals negative 8, but that's not right. Let's try this.
Negative 5?
Are we negative 5?
Or
So we
minus-
get x equals 2, and so the signs are off. What if we did this?
minus 3.
Yeah, what if we did this?
Minus terms.
Would that work better, maybe?
Yup, yup. So it'd be
See?
8. X equals 8 and
So this is an example of one where we had to, where kind of the answer is not too hard, but articulating like the equation for it would be,
negative 2.
so that would be right, huh?
I think so.
X is equal to negative 2, and x is equal to 8. So now that worked out, okay? So as far as the drawing and thinking about it, that part was easier than coming up with the right equation, wasn't it?
Yeah.
But you can see kind of by the trial and error method that we were able to do it. You guys helped me with that, all right? So that would be the equation and how you do it. Good work.
Good job.
Good job, Randy.
Now,
Go.
we come to this one right here, the flock of geese one. And this one here, I think, is a little bit more complicated than the others. And so I want to show you. So you got a flock of geese, and I don't know if you ever seen the geese flying here. You got the geese
Those white birds.
flying in a direction. They're flying like this. So
That a bird?
they're flying in this direction. That's supposed to be a bird, right? That's supposed to be a bird.
It looks like a bird.
And then you got a
Have you ever seen one?
It looks like a parrot.
Been flying over your mouth.
and then you got a camera here sitting up here. So your photographer is looking at this, and the bird is horizontally 300 feet away from her like this, right?
Shut up, Brad.
And we look at it, and it says the lead goose is flying 300 feet horizontally from her and continues shooting until it's 100 feet past. And so here's another 100 feet, right?
Yep.
That's a geese.
Oh, really? I think that's a goose.
Bro, I'm telling y'all, Miss Coastal got nothing on Mr. G.
Okay,
Is that an octopus?
the flock is flying at a steady 30 feet per second. So we have 30 feet per second, and it's going in this direction here. And write and solve an equation to find the times after shooting begins that the lead goose is at a horizontal distance of 75 feet from the photographer. And so you're 75 feet away, like right here and right here. And so this would be, what would this be? If we had this at a number line starting at 0, what would these values be here? This is remember, this is 75 feet. And this is 75 feet.
This is complicated.
Yeah, this really is. It's one reason I'm breaking it down the way I am. So you're going by here, 30 feet per second. What are you going to do with this thing? Let me ask you another question. How long is it going to take to get from here to right here, 300 feet? How long is it going to take to
About
cover
a
300
minute
feet?
and, about a minute and 40 seconds.
About 2
A little
minutes.
bit more than 10 seconds.
Yeah, 10 seconds.
It'll take exactly 10 seconds, right? Because 30 times 10 is going to get you right here. And so we're interested in how much time it takes to get between here and here. So we're interested at the time. So it's like we're considering two things simultaneously. We're considering time, and time is what we're using, and then we're trying to get these distances here.
Well, then it's just
Wouldn't it
to
be
these
10
dis-
minutes too?
5 seconds.
5 seconds, 75, oh yeah, so that'd be 5 seconds apart. So this one right here, time-wise, is going to be 5 seconds, and that's a helpful piece of information, isn't it?
Yeah.
Because that's going to help us figure out probably the equation, and if we got this thing right or not. Okay, good call, that's a really good deal. And this is 10 seconds here, okay, and we know this is 10 seconds here to get to here, right?
15.
Yeah.
And so do we have everything we need now to figure this thing out? Yeah, because you're coming right here at 10 seconds, and we know it's 5 seconds between these two.
So that's 20.
And so if it takes 10 seconds and we know it's 5 seconds in the interval here, what are the times going to be?
12.5.
So t is equal to 12.5 seconds, right? That's one of them. And also t is equal to,
Negative.
t is also equal to,
0.
how much time does it take to get from here to here?
7.5.
I think 7.5 seconds, right? Okay, and so that's just sort of looking at it, drawing, thinking, calculating, figuring out what it was. So we have what the answers are, we've solved it, but how do we make an equation to represent what this is? That's another level, right?
That hard.
So 300, and when you look at it, isn't it going to be somewhat similar to the way we did this one here? How did we did that? We made it, we ended up, was it x minus 3?
Yes.
What if we put x minus 300?
That would be wrong because you have to go, would I be saying it's going to the right, not the left? Because the camera's 0, right?
Yeah,
Yep, yep.
but see here, we went right, no, the camera's not at 0.
Camera's not 0?
The camera is at 300,
Oh.
see? And so 30 feet per second,
That's right.
so that'd be, would 30 go here, or whatever? So we would equal 75, right?
Yes.
And when we would add, well, that's going to take care of the distance for us, isn't it? Because we'd have x minus 300 equals 75, and we'd have x minus 300 equals negative 75. So that's going to get it, that's going to get the distance, right, isn't it?
Yeah.
What about the time? Because now we're interested in the time. Because we solve this, we'll get 375, which is right here. We solve this, we would get 225. So there's something we have to do to the timeliness of this to make it work.
30.
So when we multiply by we're going at 30 feet per second. So I guess one way you could do it is you could divide by that would be x equals 375. And so we could divide that by 30, right? And we could take this and add 300. So we get x in this case equals 225, and we divide that by 30. What are we going to get? What's 375 divided by 30? 12.5, right? And this one's going to be 7.5 seconds. So what we're doing is we're taking feet and dividing that by feet per second. So 375 feet divided by feet per second, the units cancel out, and we're left with this. So we're back to what we figured out a while ago, right? But isn't it kind of challenging to puzzle through what the equations are on this? It really is. I think that the other ones here are going to be as challenging.
Select the value.
Okay. This one right here, select the value or values of x that satisfy the equation. What could you do for this? What would be a strategy for this one? I would just solve this equation and you would just see which it is.
X.
Did anybody solve that yet?
Me.
Subtract 1. Subtract 2, excuse me. So we would get negative 1/2. And multiply by negative 2. Is that Randy? Would you say that? Are you Randy?
That was me.
That was Atlee?
So I agree.
So 3x minus 3 equals, and we multiply that by negative 2, we get 2. Is that right? So So we get 3x minus 3 equals 2, and 3x minus 3 equals negative 2. And then we get 3x equals 5, x is equal to 5/3. So it's going to be this one here, right? That's one of them. Okay? Then this one here, we get 3x is equal to 1, is that? So x is equal to 1/3. So what? So this one here too, right?
Yeah.
Any other values that satisfy?
No.
Now, why did you know there were only going to be 2 right answers for this, possibly?
There's only 2
Can't be more than 2, right? It's one of the first things we talked about yesterday, that there, or actually the day before yesterday, I think. Okay? So that should have been pretty simple.
Bless you.
Bless you.
Then,
Bless you.
That was very.
then we have the next one here. Okay, we have this one right here. We have, now this one here is kind of like,
Siri.
this is kind of like 17, except it really should be easier, right? How do we do this one?
Let's see. We'll...
Why is he placing himself like this?
Good point. That is a good point. Where should Terry place the dish? He wants to save the $79 installation fee.
Maybe he works for one of those.
Yeah, or maybe,
Then Tara should know.
Yo, leave Terry alone.
Yeah, maybe he should know.
okay, what do we do here, guys?
I think so.
Put a verse there. Put a verse there.
That wasn't funny.
Cucaracha.
What the?
So what goes,
Say cucaracha.
help me out, what goes on here?
let's see. I'll say 32 is the age.
It's gotta be 30.
It's gotta be 30.
So here it is, 30,
Yeah.
which is our recommended height, equals negative 3/2
X when I 16
plus 24.
plus 24.
X.
And then what?
Subtract 24.
Subtract 24, Marcus says.
Marcus light smart.
So we get 6 equals negative 3/2 x minus 16. Then what?
By the reciprocal.
Go by the reciprocal. So what's our reciprocal here? Negative 2/3, right? So we get negative 2/3 times 6 is going to be, let's see, negative 4. So we get negative 4 equals x minus 16.
That's not possible, right?
What's this?
No solution.
No solution, right?
She already knows.
You can't put it anywhere.
Yo.
So this will not work, okay? So there is no location.
Let's go.
There is no suitable.
Haley for the dub.
So that was Haley who came up with that?
You're looking at me like I'm stupid, and I was like,
Terry is stupid.
Put it
the
right there.
satellite is for TV, so you don't have TV.
Terry, you're done.
Now what would we have to do?
Netflix.
What would Terry have to do instead?
How does
You know,
Amazon-
we're not wrong.
Okay, here's what Terry would have to do. Terry'd have to say,
You don't have to have satellite Netflix?
what if Terry changed this
Netflix for
to 20,
Where does Wi-Fi come from?
right? If Terry changed this to 20, would it work?
Off the AT&T tower.
Wi-Fi box.
He'd have to actually change this to less, but you see this height has to be, this is just too high.
Yeah.
So if this height is brought down enough, the thing will work.
This house is too tall.
Yeah, this house is too tall.
His house is too tall. Well, why can't you put on the ramp?
But you see, we could change the equation and make it work somehow, right? All right, I want to thank Haley and everybody else who worked on that one. That was pretty good. Marcus. Okay, and then the last one we have is 22. So I want you to look at 22. 22 should be easier, and that's the last one on this.
Explain the error.
Explain the error. Well, the temperature is so equal.
Oh, right there, look, I see a mark.
You added 4.
No, look.
Where?
Right there. Here's what it's supposed to be no solution.
Yes.
Facts.
So there should be no solution?
Yeah.
Yeah.
Yep.
Okay.
Bro, I called it out.
Marcus done.
Yeah, negative plus negative.
Right there.
But there's no
Yep.
solution.
No solution.
Because you can't have absolute value because of a negative number. But you don't have that.
Yeah.
You do.
Yo,
Yes,
you got it?
negative 730.
Negative
Get it?
Oh, yeah, so it's-
But you have to multiply it by negative
That
number.
baby dick.
Yeah, oh, wait, okay, I see it. I was multiplying negative 7/3 and the negative number.
So this is the same thing that Haley noticed about Terry's house, right?
Yeah, Terry's house.
Essentially, huh?
Terry's house sounds weird.
All right, so really,
That's what my house looks
I was
like.
thinking old one.
so that gets us today. Tomorrow, we're gonna start talking about absolute value inequalities.
You want to pick this up or?
Yeah, go ahead, Steve, thanks.
I do.
Thank you,